All right, in this lesson, we're going to talk about outliers, okay? What was an outlier in statistics, okay? So basically an outlier is an outlier is a numerical value that is like abnormal from the regular data set. It's like it's either too large or it's too small, right? So for example, like if you have something like say your data set is 1, 2, 3, and then it's like 100, right? The outlier in this case would be 100 because 100, the outlier in this case would be 100 because it's like abnormal. It's abnormal from the regular like data set. You see how like 1, 2, 3 is like small numbers. 100 is a large number compared to 1, 2, and 3. So 100 would be considered to be the outlier of the. It would be considered to be the outlier of the data set, right? Another example, say you had something like 1, 98, 99, 100. 1 would be considered to be the outlier, right? 1 would be considered to be the outlier because 1 is the abnormal number in the data set. The 98, 99, 100 is like the regular like numbers, and then 1 would be the outlier because it's really small compared to the other numbers. You know what I'm saying? It's important to be able to recognize outliers in data sets, and the reason why is because when you have an outlier in a data set, the outlier skews the mean, and that's what makes the mean or the average. It doesn't make the mean a realistic statistic, or not a realistic statistic, but it doesn't make it it doesn't make the mean a reliable statistic because the outlier can skew the mean. You see what I'm saying? When you have a data set and the data set has an outlier, the median and the mode are more reliable forms of statistical analysis because the median and the mode are not really as affected by outliers, not really, right? But the mean can be significantly affected by the outlier if you have a really small or really large number. So for example, if we were to take the mean, if we were to find the mean, median, mode, let's try finding the mean, median, mode of example 1. Just to illustrate what we're talking about. So we're gonna use example 1 again, and we're gonna say, okay, we have 1, 2, 3, and 100, right? And we're gonna try to find out what is the mean? What is the mean? What is the arithmetic mean? Okay, so we do it right. X bar equals to the summation of x over n, right? Which is 1 plus 2 plus 3 plus 100 divided by 4. And we were to take the average of this, right? And we said, well, 1 plus 2 is 3, 3 plus 3 is 6. 6 equals 100 is 106 divided by 4. Okay. This is 26.5, right? That's the mean. The median. Well, what's the population? The population is what? There's four data set. There's 4 numbers in the data set, right? So the population is 4. The mean is 106 divided by 4, which is 26.5. The median is what? 5 for 2, which is 2.5, which means that is in the 22.5 location. So we take 2 plus 3 divided by 2, which is 5 divided by 2, which is 2.5. And then the mode, there is no mode in this example, right? Okay, so in this example, the mean is 26.5. The median is 2.5 because it's in the 2.5 location, which is here, and we divide by 2, right? And there's no mode because there's no numbers that repeat itself, right? And the population is 4, right? Population is 4 because there's 4 numbers in the data set, right? Now, let's say we did not take, let's say we didn't factor in 100, right? Let's say we didn't factor in the outlier, because this one we factored in the outlier, right? This is with the outlier. Let's say we didn't factor in the outlier and we just took the mean, like we just took the regular mean, right? So if we were to take the outlier, if we were to take the outlier out, right, the mean would be significantly smaller than what it currently is, because the mean is what is making it 26.5. You see what I'm saying? Because you have to because this is being factored in. If we were to just take 1 plus 2 plus 3 and divide it by like 3, right, we would get like, let me see, 3 plus 2 is 5 plus 1 is 6, divided by 3 is 2. But because we have this outlier here, it turns it from 2 to 26.5. So the outlier significantly affects the mean. You know what I'm saying? Which makes the mean an unreliable statistic, because it's too like changeable according to what you actually put into the data set. You see what I'm saying? If you notice, if we had 1 plus 2 plus, if we just had like 1 plus 2 plus 3, right? If we just take 1, 2 plus 3, the median would still be the same. Or it would be it would still be roughly the same, right? Roughly. Because if this is 3, then it'd be 3 plus 1 is 4, 4 divided by 2 is 2, right? So in this case, if we did 1 plus 2 plus 3, the median would be 2 in this example, because this 3 plus 1 is 4, 2. So it'd be in the second location, so it'd be 2. But see how the median is not like significant. It's only changed by like 0.5. You see what I'm saying? And there's no mode in this example either. But if you were to, but the mean in this case would be like what 2? 2 plus 2 is 5 plus 1 is 6. Divided by 3 is 2. When you factor in the 100 is like 26.5. It changes too much. So for this reason, that's why researchers and stuff like that, they prefer to use the median and the mode, because when you use the median and the mode is not as affected by outliers, right? That's why it's important to recognize what an outlier is, so that we know how to use it. Like we can identify, so we know how to how do we make conclusions about the data based on what we see, right? Let's use an example, right? Let's do something that has a mode. So let's say we had like 1, 2, 3, 5, 7, and then we had like 20 or something like that, right? In this case, 20 would be the outlier, right? Because 20 is significantly, it's different from 1, 2, 3, 5, 5, 7, right? This would be the outlier, would be 20. Okay, the outlier would be 20. In this case, the mode would be 5. The median would be what? The median is, the population is how much? This is 1, 2, 3, 4, 5, 6, 7. The population is 7. Outlier is 20. The median 8. 2 is the 4th. 1. Population is 7. 1, 2, 3, 4, 5, 6, 7. Outlier is 20. The median is what? 7 plus 1 is 8. 2. So 1, 2, 3, 4. The median is 5. Right? The mode is 5. And then the mean is, let's see, what does it mean? So we take all of it and then we divide it, right? So 1 plus 2 is 3. 3 plus 3 is 6. 6 plus 10 is 16. 10. This is 16. 16 plus 7 is 23. And so then this would be 43 divided by what, 7? This gives us 6 1/7. Right? This gives us 6 1/7, which is about, what's 6 1/7? 6 1/7 is what? 7 goes into 1 how many times? something like 6.143, something like that, 6.143. So something along those lines. If you round it, if you round it to the nearest hundred, it'd be what, 6.14. All right, so the mean is about 6.14. Okay. Outlier is 20, median is 5, mode is 5, right? Now, if you took the outlier out, right, the mean would be what? Let me see, what? 1, 2, 3, 3 plus 3 is 6, 16, 23. So it'd be 23 over 7. Which is how much? 3 and 2 sevens. And 7 over 7. 7 over 2. 7 over 2 is how much? 7 over 20 is something. 7 is 14, 6, 4, 8, 6 is 4. And 7 is 7 is 7 goes in 40, 5. Right, so just do like 3.285, something like that, 3.29. Something like 3.29. If you took the 20, if you took 20 out, right, the mean would be half. It'd be like 3.29, something like that. So when the outlier is there, the mean is like doubled. The mean is doubled. That's why we have to know, we have to know why, why we gotta identify the outlier, because the outlier significantly affects the mean. It significantly affects the mean. That's why the mean. That's why you don't want to go based on them. You don't necessarily want to go based on the mean. You want to go based on the median, right? And we will learn in the next video how the mean, like when you talk about median and percentile and all that stuff, like you gotta go based on the median and mode, because the mean is too affected by the outliers. You know what I'm saying? Invariably, you're gonna find something where they're gonna have some type of outlier. I mean, let's be real. Like everything in life, or everything that you find in a study, is not gonna be totally uniform, and that's that's just how it is. If you're researching something that's not realistic. For example, like if you're talking about height, right, in a given population, right? Let's be real. Like if the average height, like if you're talking about something like that, and we say something like, like the average height, let's just say, among like a race or something like that, is like, let's just say like it's like 5'3", right? 5'3". Invariably, you're gonna find somebody that's gonna be taller than 5.3. You know what I'm saying? So that's just not real. It's not realistic that every data set you find, or every observational study that you're gonna find, is gonna be, it's gonna be the same. I mean, in life you're gonna find outliers. That's just how it is. So in a nutshell, what you just gotta do is just, for the purposes of this video, you just gotta understand that an outlier essentially is when the number is the number in a data set looks very different from like all the other numbers. Is either very large, or it's a very small number. And what you have to understand basically is that the outlier, it's important to recognize outliers, because when you calculate the mean, median, and mode of a given data set, it affects the mean. It doesn't really affect the median and mode like that, not really. You see what I'm saying? But it really affects the mean, and that's an important thing to understand, because when we do a statistical analysis, we have to be able to understand that, because the mean is not always a reliable statistic when we are, when we apply that information into the real world. Okay, that's it. That's it. All right, thank you, and have a nice day. Bye bye.